Hi, this is a video about Chapter 3 stuff. Well, the first one's about the Linux directory structure. So I'm going to try to limit my videos, I guess, to 7. Uh, do one video about each one of these things. Maybe not this one, but anyway, and try to keep down the time, but it probably won't happen if the past is any indicator. So this first, if you go through the chapter, this first couple of images is really good, I think. Most people are really good. The first couple are really good. Most of us are familiar with Windows, so you're familiar with the drive letter. I hate the way Windows, honestly. I wish I had a specific case to give as an example, but they'll say these things are located in this directory, and you have to figure out how to get there. From like, my problem is if you click on my computer and you click on desktop or documents or C, I feel like there's like 10 different starting places when technically there's only one. It's the drive letter, the partition, but the way Windows organizes the file explorer is just weird to me. Anyway, maybe that's just a personal problem. So drive letters correspond to, I don't think it says it here this way. So what I try to do in these videos, by the way, is give you like a little bit of a different view of things that might not be mentioned in the material. Otherwise, you can just consume the material, right? So this is a partition. A partition is a logical arrangement, a logical structure for a disk. So in the Windows world, that corresponds to a drive letter. And what I mean is, both of these drive letters, C and D, could be on the same physical disk. You've got a box. Well, these days you have SSDs, right? You really should. They've pretty much matured, and they're just better in just about every way except price, I guess. Price per byte. To physical disk. I wouldn't go back unless, I don't think there's any reason to go back to physical disks, actually, because it's mechanical, right? It's electromechanical, and mechanical things can break down. I mean, in a way, the solid state could break down. There's a certain lifetime on SSDs, right? But there is on mechanical disks too. So they're just faster. No gross moving parts anyway. I guess at the very small electronic level. I'm not a solid state physicist, so I'm not exactly sure how that works. Not an electrical engineer. I'm a computer scientist, so you have to know a little bit about electrical engineering, but SSDs kind of push my limits. Anyway, that's a big tangent. Whether it's SSD or mechanical drive, like ATA, well, ATA would be the connection. But anyway, regardless of what kind of physical disk you have, the partitions may or may not correspond to those physical drives. So you could have 2 physical drives in your computer, one drive letter for each, which means that each one would be covered by one logical partition. Or you could have one disk and it could be split into 2 logical partitions. So, and that's drive letters in Windows, so C and D. You get familiar with this a bit, actually, if you install on a real machine, especially if you install Linux and Windows, say, on the same drive. You have to understand how partitions work to some extent. But regardless, it's a tree structure. So if you notice, this is the root. If you flip this 90 degrees, it would look just like this picture. So in that way, they're the same. Some of the specifics, of course, of the 2 different directory structures are different between Linux and Windows, but the foundational structure of it being a tree is the same in both. So you have a starting place, usually called the root. In this case, the drive letter is the root. For Windows, it's just called root, it's symbolized by a forward slash in Linux. Also notice, I don't know if it point this out a big deal, but to a big extent, but notice that it's backslashes that separate directories symbolically in Windows world, and it's forward slashes in Linux and like everywhere else. So that can kind of be confusing sometimes. Anyway, so it is what's known as a tree, which is a connected, undirected acyclic graph. I've had a couple graph theory, one graph theory course. It's a neat subject. Why am I bringing this up? Because the very structure of these, the tree structure, and again, acyclic means that you don't have any cycles. Like everything has one parent. You notice the F doesn't connect, for instance, to A and make a big loop. If you can go around in a circuit, then it's not acyclic. That's why cyclic means you can go in a circuit, right? And a cycle. There's no cycles in this. And this is handy, this structure, because it's recursive. So what I mean by recursive, a recursive thing is where the pattern, the general structure of the thing is repeated all throughout the parts of the thing. So for example, if you notice, this is a tree, right? It starts with A, there's a root, and it has branches down, and everything has at most one parent directory. If it had more than one parent, then it would have a cycle, which would make it not a tree. So everything has at most one parent. Now, if you cut this right here and get rid of the A and B, you still have a tree, and so on. So the pattern repeats the further down you go. Trees have subtrees, which are trees themselves, right? Which also have subtrees. That's what a recursive pattern is. Recursive means literally to run back on itself, but here it repeats the big structure is repeated in all the parts. There are algorithms that make traverse is called traversal, where you go and visit each thing. You can think of these as leaves, maybe each A, B, C, D. You can visit all those nodes or leaves using recursive algorithms. It's very straightforward and easy. So for example, if you're looking for a file in your Linux structure, your directory structure, let's go back to it, this thing, you can use your recursive algorithms to traverse and look in each one of these places in an efficient way, or straightforward way anyway. The algorithms are all there. So it helps computer science wise for this to be a tree, is what I'm the long and short of it. You don't have to remember all that stuff I just said, but knowing that it's a tree, there's a reason why it's a tree. Several probably, but one of them is that the whole traversal thing is straightforward if it's a tree. It could have been designed where you had like what would be called a network graph. I guess it could be designed that way, where you could have more than one parent. There might be pros and cons to it, but the whole recursive search wouldn't be the same. Anyway, so Linux specifically, the root directory symbolized by the slash. Of course, the root is the user, who's the like super user administrator equivalent in the Linux world. There is a home directory right off the slash, the root directory for root, called root. So don't be confused by these two things. This is the root directory. This is the home area of the root user. Two different things. So when somebody says the root directory, they're not talking about the thing that's actually called root. So that's kind of, I hardly ever even think about this. You get used to it after you use Linux for a while and you don't even think about it, especially if you have like your own installation where you're root. But yeah, the root directory that's spelled root's not the root directory. The root directory kind of doesn't have a name. It's just got a slash that symbolizes it. So root directory is at the top with a slash. Then you have several subdirectories. They've got etc here, which is good because it's a standard one you'd have at this level. You also have bin, sbin, user, usr, right? Local. There's a few others. They have differing purposes on different distributions. They have the same general purposes usually, but sometimes there's a little differences between the distributions. Etsy usually has configuration files for different, typically, I'm going to say, what's the word? Server type applications that are running, but also just about any application you have might have some Etsy settings. You would go in here to do it. This is usually root access only, but there also will always be a home area somewhere. It's usually right off root. I haven't seen where it's not off the root directory. So each user will have a home directory in the name of the account typically. So Sue that logs in with Sue will have a home area called Sue. The things I was saying about physical versus logical before apply also here. You could have everything over here on one disk, all the like Linux installation system stuff could be on one disk, and then all the home areas could be on another disk. So that way you could reinstall the system on, say, disk 1, hard disk 1, and it wouldn't affect the home area on hard disk 2. You just mount this into the file structure. It's called mounting. Mount in that physical disk that has home on it into the overall logical structure of your Linux installation, and then that way, say you delete, or that even that hard drive just fails, you can install Linux on another hard drive and then mount that home area in there, and the users haven't lost any of their data. That's one arrangement. Later on, I'm sure we'll all learn about. I'm not like even an expert myself on how all the different schemes for doing physical versus logical are. The fanciest I ever got was doing RAID 0 with 2 SSDs, which was super fast. But anyway, and that was for both Windows and Linux, I think. But anyway, I think that's enough about the directory structure. Just know that it's a tree. The whole recursive nature of a tree makes it easier to like navigate and traverse through it. And know something about the partitions too. I don't know if that's actually tested here, but it's something you should know anyway, that there's a difference between a physical disk, which is the actual mechanics box, or the SSD, the circuitry, whatever you want to call it, the actual physical thing you hold in your hand, and a logical partition, a logical disk sometimes it's called, which in Windows corresponds to drive letters, and Linux could correspond to really anything in this big structure. This could be one big physical disk. This could be 4 different physical disks mounted in different places in here. I think that covers directory structure. The next lecture will probably be on the changing directories, which includes stuff about absolute versus relative path names.